Welcome to another video. So today we are going to look at the organic chemistry solutions in the IIT JAM 2020. Okay, let's go into the first question in the organic chemistry in that IIT JAM question paper. The correct statement for the following structure is three structures are given. The resonance structures, the first option is 1, 2, 3 and resonance structures, and 1 and 2 are resonance structures, whereas 3 is an isomer of 1 and 2, and 1 and 3 are resonance structures, whereas 2 is an isomer of 1 and 3, and 1 to 3 are constitutional isomers. So first, here, as you can see here, the question is about the whether resonance or not. So resonance is the delocalization of the pi electrons. So in the given structure, these are not resonance structures, since the hydrogen shift is also taking place, as you can see here, and like it's changing over here and here. So if only the localization of pi electron, it should be resonance. So here the hydrogen shift also taking place. So this can be the answer of the question will be the option D. 1, 2, 3 are constitutional isomers. Okay. Okay, going to the next question. The correct order of the boiling point of the compounds 1 to 4 is, the 4 compounds are given and the order is also given. So here there is a straight chain alcohol over here, first one, and then both branched alcohols. So when the branching comes, whenever the branching comes, the boiling point, number of branching will be increasing, the boiling point will be decreasing. And since there is this alcohol, there is a possibility of hydrogen bonding. So hydrogen bonding comes, the boiling point will be increasing. So since these two have branching, so the highest boiling point will be for 1. Okay, for 1. And then here this one does not have any branching at all. Okay, so the least boiling point will be for 2. I hope it's clear. And so these two options can be neglected. So from this 3 and 4, which comes first? Having higher boiling point, we have to find. For that, the molecular weight is also directly proportional to boiling point. So as you can see here, this have one extra carbon, so it is having higher molecular weight than here. So since the molecular weight is higher, and boiling point will be higher, so the options will the first will be this one, and then goes the third one, and then goes the fourth one, and then comes the second one, and the option will be C. And going to the 8th question. So it's a treatment of formic acid with concentrated sulfuric acid. So here concentrated sulfuric acid is used. So the formic acid, that is HCOOH plus H2SO4, will give as you know, the sulfuric acid is a strong oxidizing agent as well as the dehydrating agent. So it will produce carbon monoxide plus hydrated H2SO4. Okay, so the products will be this one. So option A is the answer. Going to the next question. The amino acid with the R configuration is, we have to assign the each atoms with the according to the CIP rule. Okay, so I will assign each of them. So here first we have to give the priority like this. So the least priority is for hydrogen, as you may know. So the higher the atomic number, given the higher priority. So least priority is for hydrogen, so I will give 4 for all of them. And then going to the highest priority is for directly connected to nitrogen, so highest priority is for this nitrogen in all of the cases. And going to the next priority, so how can we assign the priority of the each of the vertical positions? So here, going to here, so here the carbon is connected to oxygens, and since there is a double bond, so 3 oxygens. Okay, so and here only 2 hydrogen and 1 carbon. Okay, so the priority goes like here 2 and 3. Okay, so as you can know, 1, 2 and 3. Okay, so the configuration will be S configuration, so this is not a option. Going to the next one, here the priority goes to here. This carbon is having connection to the, okay, let us again look, and this carbon is connected to 3 oxygens, 1 2 3. Okay, and this carbon is connected to 1 sulfur and 2 hydrogens. So the priority goes like here it will be 2 and here it will be 3. Okay, so this is the R configuration. So this will be the answer. So let's also check this also. So here if we give priority, this carbon is connected to 3 oxygen, and this carbon is connected to 1 carbon and 2 hydrogens. Okay, clear? So the priority goes like this will be 2 and this will be 3. This is also S configuration. So next, going to here, this carbon is connected to 3 oxygen, and this is having similar like this. Okay, then the priority goes like 2 and 3. So this is also S. So the answer is B. The major product formed in the following reaction sequence is. So here the first step is the Grignard reaction, this one. So here since it is having delta negative, so it will be attacking here, so its ring opens and it will give O minus and Et. Okay, and going we will get like OH Et, and then the second reaction is CrO3 oxidation. So here what happens is that this double bond will get oxidized and we will get, okay, and then again if we treat with this is the Wittig reaction. So here upon Wittig reaction we will be getting so answer to the option is B. We hope you understood this. So this is the Grignard reaction. So first Et minus will be attacking this carbonyl group, and then we will get this. So second is the CrO3 oxidation. So here it is tertiary alcoholic group. So since it is a tertiary alcoholic group, it will give rise to alpha beta unsaturated ketone like this. So this alpha beta unsaturated ketone like this, and then this final step is this is lide. Lide will react with the carbonyl group to form this double bond. So this is the Wittig reaction. Products formed in the following reaction is. So here the question and options are given, so let's check. So here what will happen is that since this is a base, so it will take the hydrogen over here, okay, and it will form methyl OH, and here there will be a negative charge, okay. So this will attack this curve and bromine will be gone and form a compound like this, okay. Then to this compound OMe will be again attacking on the carbon group, and the carbon group will be opening, giving this one, and this O minus will be again taking here, and this chain will be open like this, and thus we will get like this, and then this negative bond will be going for this and will form out, okay. Then what we'll get a double bond over here, so PHMe double bond over here, and then OMe, okay. Option of the question 25 is A, this one, okay. Going to the next question. Rate of the solvers is of 1 to 4 follows. The questions and options are given. So here the solvers is directly dependent upon the stability of the carbocation. So here whenever the bromine is going, so here there will be a carbocation, here there will be a carbocation, and here there will be a carbocation, and here carbocation. So when we check all of this is aromatic, and this is the anti-aromatic. So the carbocation will be more stable here and least stable here, okay. So it will be third will be the most stable one, and the least stable will be fourth one, so the option will be C, okay. Let's go to the next question. The most stable species in the each pair of conformers are, the options are given, so let's look. So first when we compare here 1 and 2, here there will be hydrogen, and this is CH3. So and when we compare this one, here also there will be hydrogen. So this will be, since there will be more steric interaction over here, so this will be least stable, and this will be more stable. Again when we compare to the structure 3 and 4, so this one will be least stable, and this one will be more stable, okay. So there is no 1,3 diaxial interaction over here, and going to the fourth structure, there is a possibility of the hydrogen bond over here. So this hydrogen I am writing like this, so there is a possibility of the hydrogen bond, and so this structure will be more stable, and this will be least stable. So the correct answer is option B, okay, 1, 4 and 5. So here it is more stable, and here it is more stable, and here it is, this is more stable. Okay, sorry, this is more stable. Here, since the hydrogen bond can be happen due to, since this is on the equatorial position. Okay, going to the next question. The major product formed in the following reaction sequences. So here it is titanium chloride is used, and this is nothing but McMurray coupling. And this is nothing but the formation of the alkene by reductive coupling of an aldehyde or ketone using a covalent titanium reagents like this. So the answer will be this one. Okay, see, going to the next question, Diels-Alder. So here for the Diels-Alder reactions, the activation pairwise follows the order. So here let us check the, so these are the reagents: thiophene, cyclopentadiene, and furan, and pyrrole. So since thiophene is more aromatic, so this will be having the highest activation barrier, okay, for the Diels-Alder reaction, and then comes for the pyrrole ring. Okay, and since the furan is least aromatic, this is least aromatic, furan is least aromatic, and since it will be having lesser, and then comes cyclopentadiene. Okay, so let us check whether how the options are going. So this is 3, then comes pyrrole is 4, and 2 and 1. So 3 4 2 1, 3 4 2 1. This is C is the answer maybe. Okay, going to the next question over here. Yeah, okay. So going over here, the question number 30. So the major product formed in the following reaction is, so here there is iodine and a base. So there's a alkene. So it is iodolactonization. So first this iodine will be interacting with the alkene group, giving this iodonium ion. This is the iodonium ion. Okay, so then since there is base, this here, this one will be, this hydrogen will be abstracted, so it will form O minus. Okay, the base will attack, and this O minus will be attacking this carbon, and then like this. Okay, so whenever this attacks, this iodine group and the COH group will be trans to each other. Okay, so and since these, both of these are from the same direction, so both of this will be in the same side. Okay, so let us check. Here this is also up, this is also up, this is also up, so this is down, this is both are up, so this will be the option. Other options are also given, so this is not a possibility, this is also not possibility, so the B is the answer. Okay, going to the next question. So here the question is, achiral stereoisomers is or are possible for these compounds are. So first one is, this is alanine molecule, allyl molecule which is optically active, and this is biphenyl and this is also optically active. And here for this one, it is we can see here we have a plane of symmetry, so this is achiral, and again here also there is a plane of symmetry, so this is also a chiral, sorry, a chiral molecule. So both of these are optically inactive. Okay, so the options are C and D. These two are wrong options. Going to the next one is this. So question number 38, the compounds which have only two signals in the H1 and NMR spectrum in 3:2 ratio is or are. Okay, so here if we check, this will give a proton, and here also there is a proton, p proton, and here is also a proton. So there is, they will give 3 peaks. So here the questions will have only 2 peaks, so this is not the answer. So, okay, and here also if we check, there will be a proton over here for this CH3 and one proton over here and another proton over here and here also. Okay, so there will be 4 peaks, so this is also not the answer. Okay, then going to here, there will be a proton here, a proton here, and a proton here. So this will have 2 peaks, and when we check here, they will have this proton over here, proton over here. Okay, this will also give 2 protons. So we have to check the H1 spectrum in the 3:2 ratio. Okay, so here there is CH3 protons over here will be 6 CH3 protons and 1 2 3 4 4 methyl protons, so this will be giving rise to 3:2. And here also if we check, this is CH3, this is CH3, so 6 CH3 proton and 2 plus 2 4 CH2 proton, and this will also give 3:2 peak. Okay, so the options will be both C and D. Okay, going to the next question. The correct sequence of the reaction for the synthesis of the following molecule is or are. You have to find the correct sequence of the reaction. Okay, so when we go into the first option, iodophenol, when we treat with the Grignard reagent, okay, what happens here? There will be MgI, IMG. Okay, then again treat with the cyclopropane carboxyaldehyde, that is this one, cyclopropane carboxyaldehyde. Okay, so this will be reacting to, okay, this will be reacted to here. Okay, which will give rise, and this group will be here, then I'll write over here result, and upon workup it will be OH, and then we treat with this reagent. So this is reagent, see here, this will be OMe. Okay, so we will get a secondary alcohol over here. Okay, and so we can get this by these reagents, and we can check the second reagent. So again, cyclopropyl bromide, that is cyclopropyl bromide plus not reagent Mg ether, we will get this MgBr here. Okay, and then when we hydroxy benzaldehyde, that is aldehyde, we will get what we will get, how this will be attacking over here. Okay, so we will get this will be O minus CO minus, and when we work up we will get this hydrogen, and again when we use this reagent, this group will be OMe. Again we will get the same product, so this is also a possible reaction. Okay, then going to the next option. Going to the next option is idophenol. This again idophenol, OH, okay, plus this reagent will be treated, and here it will be OMe. Okay, and again if we treat Grignard reagent, so here it will be when we treat with Grignard reagent, here it will be GI, and then we again treat cyclopropane carboxyldehyde, as we have seen earlier. Here it will be double bond over, so this will be reacting over here and giving the same compound, this one only. So again this will be also an option. And if we check over here, what will happen? Cyclopropyl bromide. So cyclopropyl bromide. So if we treat with the Grignard reagent, it will be MgBr, and then treating with the methyl for methoxybenzoate. So and OCH3. So here if we react, it will give an tertiary alcohol only. So like this. So here we, sorry, it will be reacted to give an tertiary alcohol over here, and so group over here and another group over here will get a tertiary alcohol group when we react this. So this is not option, so A, B, C and A, B, C is the correct answer. Okay, going to the next question. Going to the question number 48. Okay, the total number of constitutional isomers possible for trimethyl cyclohexane is. So trimethyl cyclohexane, this cyclohexane with a 3 methyl groups anywhere. So maybe the answer total number of the constant isomers possible is 6. Okay, going to the next question. The dihedral or torsional angle in degrees between the two methyl groups in the most stable configuration of N-butane is. Okay, Okay, this will be the most stable conformation of the in butane. We can write it like this. So methyl back hydrogen hydrogen methyl. So since the methyl groups are in the two different positions, so there is no steric interaction between. So the methyl, the angle between the two dihedral is 180 degree. Okay. The degree of unsaturation double bond equivalent for a compound with a molecular formula C14H12O2 is. So the equation for the double bond equivalence is C plus 1 minus H by 2 minus X by 2 plus N by 2, sorry, N by 2. Okay, so if we calculate for this, we will get here carbon is 14 plus 1 minus here the hydrogen is H12, so 12 by 2 is 6, so 15 minus 6 is 9, so the answer is 9. Okay, going to the next question. The total number of tautomers possible for 1 and 2 together is. So here for the structure 1 there is 2 tautomers possible since both of the sides are same. So and for this structure, since here it is methyl and here is phenyl, here there is 4 tautomers possible. So in the total there will be 6 tautomers. Okay, going to the next question. The total number of tail isoprene linkages in the following molecule is given. So this is the isoprene molecule. So here it is the head. This is the head and this is the tail. Okay. So if we calculate, so if we check this is okay. So there is the total number of head to tail isoprene linkages in the following molecule is 4. So that's the end of the question paper. Please let me know if you have some doubt or something. So please subscribe to this channel and share it with your friends. Thank you very much.